Okay, now we're going to add the cap. So you can see what we're doing. We're going from the lowest parts to the highest parts. That's generally how you want to do it. Generally, that's how you want to do it. Only because if you start putting the taller parts in first, they're just going to be in the way. That's it. No, nothing magic. Just a practical thing. Okay. Now I'm going to start adding caps. For these, I'm not going to be able to use the tape. These actually have to be off the board just a little bit. And I'll show you why. But the first thing I want you to see, these caps are filthy. Can you see all that dirt coming off of there? They are absolutely filthy. These need to be cleaned. Sometimes my cleaning, I think, is maybe a little anal, but boy, there's some parts that are just absolutely, it's like they were made in an oil field or something. They're just ugly, ugly, ugly. And these particular caps happen to be like that. These are top maize, I think. Probably. I can't tell. I'm pretty sure these are top A caps. Top A metal film caps. Now, for these, we're going to do something else. What you could do is just hold them down like that and bend them out and cut them, and that would work, and your boards would probably be fine, and there wouldn't be any issues for a while. However, let's look and see what happens here. You can see when they're sitting right down, right? Especially with the smaller ones, right? There's no lead there. See, the lead is, see that? Now you can see some lead. Like there, the package, this candy coating here, that's called the packaging, is intruding into the solder area. In fact, some of these are really bad. Some of these have some of the packaging actually running down the wire. That is a big no-no. That would fail any inspection on the planet. Now, I see that all the time, but that's not how we do things here. I actually made a little test board just to see what would happen, and you can see, like for example, some of them you actually flow through a little bit to the top. Still, you can't see it, but on the inside there's no flow on the inside, and this coating here has intruded into the area. You absolutely just can't do that. That's such a poor way of doing it. You can see on this one here, the coating, the packaging actually goes into the lead, and it's sitting in the hole. Sitting in the hole. What a terrible joint. What a terrible joint. You don't want that. Okay? So what we're going to do, we're actually going to, here's the completed board. We're actually going to make sure that these are off the board just a little bit. They're going to be standing up just a little bit. There's a number of ways you can do it. You can get these actually bent so that you have a standoff distance. However, a very simple way of doing it, which I'm going to show you. And right or wrong, it's how we do it. Well, it's not right or wrong, it's right. What I'm going to do, I'll show you with this one here. I'm actually just going to push it up a little bit, not much, just a little bit, and just kind of hold it there. And then I'm going to come from the back, and I'm going to bend them out. See? And I'll show you what we end up with in a second. Just let me do it. You don't want these too tall, but okay. So you end up with a situation like this. When it's flipped over, they're actually off the board just a little bit. Okay, see that? So nothing is intruding. And then the way we're going to cut them, if you just tried to cut them now and didn't take this next step, you would have a little bit of trouble. And the trouble is that you would never actually cut them down at the proper level. What you need to do to cut them is you actually need to hold it, push it down, make sure it's actually seated properly, and then I come in from the top and just nip them like this. So again, you know, people make such a big deal about cutting these things before soldering them. As you can see, it's really not a big deal. Even if you don't use the tape, it's just not a big deal. Well, why do so many people cut them afterwards? I don't know. It's the wrong way to do it. Unless you take those additional steps that we talked about before. And it's so easy to do it like this. Okay? Now you know how to do it. Let's quickly get these soldered in. Nothing special about it. Just going to do it exactly the same way that we did the other ones. Then I'm not blowing on the joint to cool it, I'm just blowing some of the flux fumes out of my face. I'm going to examine the joint. Joints are nice. Joints are nice. No cold joints, no big globs. Very happy. Let's add the other caps to it. The reason I do this in stages is because these caps run 90 degrees to each other, and if you try to do them all at once on this particular board, they interfere with each other and it just makes it harder to do. So we do them like this. This cap is a high quality ceramic cap. It's a non-microphonic cog. C0G, I think, or also NPO, I think. Style cap, very high quality ceramic cap. Where it happens to sit, you really do want a high quality ceramic. You don't want a microphonic cap right here, and you also don't want it to drip. You know, a lot of caps, especially ceramic caps, if you buy a cap from Radio Shack, you buy a ceramic cap from Radio Shack, what you're going to get is a capacitor whose value is practically unknown. They're designed for like power supply, filtering, and things like that, where they have to be a minimum value, but can be much higher. If you're going to use a ceramic cap anywhere in the tone path, you want to get a high quality, high tolerance cap, or you're not going to know what the heck is really in there, and you're going to find that your circuits are they're not going to sound right from build to build. They'll all sound a little bit different. So that's my little spiel on ceramic caps. There's nothing wrong with ceramic caps, but you know, use the cheap ones where you can, and use the better ones where you have to. In my opinion. It's just how I work. Okay. Again, nothing magic here. Okay, very nice. A couple more caps, and this board is practically done. It's taken longer than I thought, but no, you can't rush this stuff. Obviously, when I'm cranking these out, I'm not talking. I'm just building, and it goes much faster. But we still take. Every step is exactly the same. We inspect every single joint. We make sure that everything's right. If it's not right, it gets redone, period. There's no junk that leaves here. It doesn't leave until I'm happy with my name on it. Again, we're going to do the same thing here. Okay, I don't know if you can see it. I'm just doing the same thing. I'm introducing a little bit of standoff by pushing it up slightly. Okay, and bending them. Okay. You see what I'm doing? Maybe. Okay. Every now and then I cut them just a little bit too close and they fall out the other side. Which is not a big deal. Just put in a new one and continue. There's a couple of ground plane joints here, a couple of thermal reliefs, so we're going to go a little slow on a couple of them. Okay. If you see me slow down for a second, that's why. Throw the bypass caps for the power supply section. Yeah. It's the only place I use the electrolytics. Really, the only place you should, in my opinion. Because they're not great, you know, they drift. They're not designed for high precision. They're designed to handle, you know, they're designed for big capacitances and high voltages and bypassing power supplies. That's what they're designed for. So why put them in the signal pass? It's not like you can't buy other caps that fit there, right? Yeah, I'm happy with that. This particular one didn't flow that great. I wonder why. I can normally see it from the top. It looks great. I just didn't add enough solder. Okay. This particular one, not a big deal. I can reflow it. Not reflow it, but I can just add just a little bit from the top. It's actually fine the way it is, but I'm going to add just a little drop from the top. Okay. Couple more caps. That's still a metal film, even though it's a box style. Again, absolutely filthy. Really ugly. I mean, some of that. Look at this garbage. I'll show you. Look at that. Oh, awful. Terrible. Okay. Same thing with the little metal film guy here. Give a little bit of standoff and go. This guy here can go straight down. You can't see it probably. This guy go straight down to the board, the box one. You can't see it, but there's actually little standoffs built into the box itself. So that's not going to be right down onto the board. Okay, this one's designed to be right on the board, but there's not going to be any intrusion of the plastic because that's how it's designed. Okay. All right. Last one, and then we're going to clean it. And you're going to see how pretty these joints are. They probably look really ugly now because of the flux. But I can tell you that these joints are great. They're beautiful joints. A little bit slower on the ground plane. Actually really didn't like the way that flowed. Yeah, but it looks good. Did it flow through to the top? It did. Again, I'm going to do very careful here. I'm going to very quickly just reflow that right there. And I'm also going to reflow it from the back with an extra drop of solder just to make sure. It's probably fine, but funny that way. There we go. That's better. Oh yeah, that's much better. Okay. It's not a disaster. If I had to, I would simply remove that component and clean it and resolder it. That's it. Not a big deal. We do that sometimes. Normally though, we're pretty good about it. Okay. Now we're ready. I've examined all the joints. All the joints are great. There's still a couple of components that we need to add. We're going to clean it. This time we're going to clean the board because I want you to be able to see it. And I would never clean the board with these pots on here. because it gets very difficult to clean underneath the pots. So we just live with any sort of flux there. Once I get an ultrasonic cleaner, I may decide to just simply clean it with the pots on, assuming that the cleaner doesn't destroy the pots. Well, that's the other thing too, is I really don't want to get any of the cleaner and the flux and all of that actually into the pots too. I had a little bit of an issue with that at one point as well. So we're going to leave these pots off until last, and we're also going to leave the LED off until last, and you'll see why. So we're going to live with the flux there. But let's clean it, and then so right now it looks pretty good. It really looks pretty good, and it doesn't look bad. This is how it would normally go out. All that flux, that ugliness there, to me, that looks great. To me, that's telling me I've properly heated all of the flux, and it's doing its job. That's good, very good. If your board looks like this, you did it right. If your board looks black or brown or something like that, you know, you need to work on your technique and your temps and timing and stuff like that. So, but I'm very happy with that. Okay, I'm going to again clean it. Same procedure, nothing different, except this time I'm going to blow it off with a heat gun. Okay, same procedure. I'm going to come. I'm not going to do anything to the top here. I haven't applied any flux to the top. There will be just a touch of flux. It's migrated from the back, and there'll be some that will migrate through these holes too. Okay, so we do need to clean the top, but we don't need to scrub it. What I'm going to do is scrub the back, okay, and then I'm going to quickly spray the back and the top, so anything that's dissolved will stay dissolved, and then we'll get blasted off, and then we'll rinse with the IPA, not IPA, but whatever the alcohol mix in the sprayer is. Okay, and then we'll dry it, and we'll see what we have. This is going to look great. You ready? Here we go. Don't want to use a lot of this again, because it is expensive. And also, the less of this I use during this step, the less is going to migrate to the front of the board. But I do want to make sure this is all completely dissolved. All completely dissolved, and I want to have enough on there that it stays dissolved. I don't want this to evaporate until I'm ready. Blast it off. Smells good. Rinse. This is cleaning too, but I think of it as a rinsing step. Okay. A little bit. Grab a couple of these, get off some of the excess. Now you do need to be a little careful during this particular step. Grab my trusty, this is my heat gun that I use. You can use a regular heat gun too, and I do. But I picked this guy here up especially for doing this and for heat shrink. Because it's small, and it's not quite as hot as the industrial ones. It's a little more appropriate. And notice I have my hand behind here. Okay. Now this is very hot. This gets actually hot enough to melt solder. Really, it does. So it does get extremely hot. But I'm moving it around and I'm keeping it cool. And I have my hand behind it to make sure that I'm not getting too hot. Okay, if my hand starts to hurt, then I'm too hot, I'll back away, or I'll go back and forth a little bit faster. So I'm making sure we're not putting any stress on here whatsoever. We're just drying with a little bit of alcohol on there. Very nice. That's done. I better turn my heat gun, my glue gun on there, because we're going to be doing that in the next video. And now I'm going to examine this. Oh. That looks great. That looks beautiful. Look at that. That's just beautiful. This could have come out of a wave soldering. That's just gorgeous. Look at that, all nice and shiny. Nice, perfect little joint. That's great. Look at the top of the board. Oh yeah. Yeah, all right. That's great. That's what you're looking for. When you're cranking along, you should be able to crank these out in 30 minutes, 20-30 minutes. We went very slowly here, but you start to get into a rhythm, and you start to crank. to crank on these, okay? But that's what you're looking for. No big solder globs. Nice. You can see what they call the concavity of the joint. That means it's flowed. Everything's gotten hot enough. The solder's had a chance to wet the joint. The surface tension of the solder, because it wets, wets the metal. It sticks to the metal, and the surface tension of the solder forces it into this sort of concave shape. That's what you're looking for. If you have a big glob, then that probably means that it did not wet enough. And you'll often get that when you try to keep resoldering the same joint without adding flux or solder. That's what happens. It doesn't flow, it doesn't wet, it does all sorts, it does everything bad. This is everything good, okay?